Anybody, questions or comments? Yeah. I can't hear you. Yeah. Are the answers posted on Math1030? Is that the? So at one point, it was set incorrectly, so you couldn't see the answers, and I changed it so that now you should be able to see the answers right away. If you answered before I changed it, I'm not sure what happens to you, if it changed the setting or not. In any case, you should be able to see them now. I still can't hear you. Yeah, guys, can we be quiet so I can hear the question, please? Yeah. Yeah. Yeah, so you should be able to see, now it should be set up so you can see the right answer as soon as you answer, and that is the setting that I want. If it's ever not set like that, post it on CampusWire and say, hey, the setting is wrong, and I'll go ahead and fix it. Yeah, that's a good point. Okay. All right, so let's do this question now. A function is like a blank, and I want you guys to tell me what is the blank. Let's see what you said. Of course, there's no right answer, right? It's just for fun. Okay, a function is like a life. Okay, this is a good one. 2 people wrote this, right? It's an input and output relationship. That is great. I like the input and output. Of course, it would be even better if there were spaces, but you can't do spaces. Input, output, very nice. A relationship. So some people are saying relationship. And just be careful. Every function is a relationship. So relationships can be functions, but sometimes they're not. So some relationships are not functions. So a function is a relationship with, it has some extra properties. Same thing for the equation. So every function is an equation. So equations can be functions, but equations might not be functions. So watch out for these. Let's make a list of these false friends. So like functions definitely, what are they? Input-output relationship is definitely a function. Input-output. And then I think I'll make a category for maybe. Things that can be a function or they might not be a function. You got to be careful. And so we said relationship or relation. So a relationship might be a function, it might not be. A graph, that might be or might not be. An equation, it might be a function, it might not be. So you got to be really careful with these ones, because if your brain says, oh, that's exactly the same as a function, then in situations where it's not, you're going to get mixed up. So maybe not a function, maybe not a function. So watch out for these ones. That's why I asked you guys this question, to get these ones all out of the way. A rule, okay, some rules are like that. Input, output, again. Adding alphabet to math, I like that, very nice. So why functions are the point in math, like when you're doing math and you're a kid, you're just like numbers, everything's fine, and then all of a sudden there's alphabets and functions and things. The reason we need alphabets is because functions are about what happens to a generic input, right? It's about an input-output, and I don't want to say what happens to the number 2, I want to say what happens to any possible number. That's why you need letters for functions. Pain, this is the last class had a lot like this too, pain. Machine, this is very good. I like this, machine is good. This is a good one. A machine. What other ones did people say? A function is like a function. Yeah, true. Very good. Input-output machine, very nice. Y equals mx plus b. Okay, again, y equals mx plus b is an example of a function, but that's not like what a function is. A headache that won't go away. Okay, maybe we'll stop. We'll stop there. So some people, I'm sensing, have some trauma associated with functions, which is true, yeah. A burden. All right. So let's stop there. I think we're getting the idea. So I like to think of a function. I'm going to add mine. Machine or input, output, these are perfect. I would add the idea of a factory. So why is it like a factory? What does a factory do? Well, a factory is like a big conveyor belt. This is my like cartoon math brain of a factory. It's like you have this conveyor belt. These are supposed to be wheels, by the way. It's not like a caterpillar or something. And it's a conveyor belt with like little robot arms that do stuff, right? Like they do stuff to the things on the conveyor belt. And a factory, maybe the input to the factory is some material. This is some material. And then we put the material on the conveyor belt and a bunch of robot arms act on the thing, and then they pass it to the next guy and they act on it. They put in screws, and out comes something useful. So here is my example of a factory where the input is maybe the input is something like cotton or something, some material, and the output is something useful, like a t-shirt, right? And the point is, in this factory, we're just doing a sequence of steps on the input, and we pass it to the next thing. We do all the sequence of steps, and then we get the output. That is what a function is like, right? So there's some number, which is x, and then you do a bunch of operations, do stuff to x, do stuff to x, do 2f's, and then you get f of x, which is the output. And so that is what a function is. It's this idea of the machine that is doing the processing on the input to give you the output. And it's really important to have this idea in your head because there's all these other things like relations, graphs, equations that are related to functions, but you don't want to get mixed up, and you want to remember what is the actual function. It's the factory that is doing the stuff to the x to get the f of x. And OK, this is written a little bit more formally and a little bit less hand-wavy in this next thing. A relation between two variables is called a function when there's always one output for every input. And it looks like this. So here's a picture of it. You have the input x, you have the function f, which is doing the processing, and then you have the output f of x. And again, this is where you need to use letters because x doesn't represent any individual number. X is the idea of whatever the input is, do stuff to it. We're going to see some examples in a second. All right, any questions or comments? OK. So here are some examples. And this is a nice warning as well. Be careful. We write f of x, right? We write f of x, and it looks maybe like f times x. But f of x represents, this is the number you get when you input x into the function f. So this notation, f with brackets, it doesn't mean multiplication. Please watch out for that. Some people will do things like they'll do like f of x divided by x, and they'll cancel out the x's. Don't do that. This is don't. No. OK, so watch out for stuff like that. This is a little tip to help you. The first thing you're going to learn to do, here are some really simple examples, plugging in numbers into a function. And you guys are going to show me that you know how to do it on Math1030. So we're going to do this one. Plug in some numbers. And this should be pretty quick. I'll give you like a minute. It hasn't changed. Thanks for that. That hasn't changed either. OK. It's working for some people. Let me see. You might need to reload. Yeah. You let me know if it's a problem. OK, 10 seconds left. Put in what you think for these two values, f of 2 and g of 2. All right, let's take a look. What did people say? F of 2 is 128 people out of 136 said 4. And over here, 130 people said 2. Those are the right answers. So most people got it right. Very good. Let's see, what else did people say? OK, maybe some people who are guessing. E, no, OK. So let's go back to notability here. So yeah, f of, the moral of the story is recognizing what this recipe tells you and how to use it. So when someone says f of x equals x squared, there's a lot of people chit-chatting. If we get you guys to quiet down. OK, thank you. So f of x equals x squared is a recipe that says whatever the input is, square it, right? So this is the machine that takes in something and squares it, the squaring machine if you want. So if you do f of 2, it's 2 squared, which is 4. And this is the 4 divided by machine. Whatever you feed into it, that's called x in the formula. You do 4 divided by that, And that's the answer. So in this case, it's 4 divided by 2. We fed in 2. You get 2. So most people did that correctly. You're going to see it's going to get slightly more complicated because we can feed in not just numbers like 2, but otherwise more complicated expressions and keep track of what happens. So we're going to see that in a second. One thing to watch out for is what is not a function. And some equations are not functions. So in this little definition 16, it's warning you about implicit equations. An implicit equation is a relation between x and y of the form fxy equals 0. This basically says the x's and the y's are jumbled together. X's and y's jumbled. Jumbled. How do you spell jumbled? Jumbled. So a good example is the relationship x squared plus y squared equals 1. X squared plus y squared equals 1 is a relationship between x and y. We're talking about the values of x and y such that when you square the x value and you square the y value and you add them together, you get 1. That's the relation. But it's not a function, or at least it's not an explicit relation. So an explicit equation is of the form y equals f of x, and it has this input-output flavor. You can see exactly what y is in terms of x, just like the examples we did. So you got to be careful because implicit equations are sometimes functions, and they're sometimes not. Sometimes you can turn them into an explicit thing, sometimes you can't. So watch out. Watch out. And that is one example, is x squared plus y squared equals 1. We're going to see exactly what that looks like in a second. So x squared plus y squared equals 1, also known as x squared plus y squared minus 1 equals 0. This is an implicit equation. Implicit. And f of x equals 6x squared minus 2. That is explicit, right? OK? And every function out there, there is some way, if it truly is a function with an input and an output, there is some sequence of steps you can do to go from the input to the output. Sometimes it'll have an explicit equation, and sometimes it won't. So you got to watch out for this. This is one type of way to specify a function, is to give an explicit equation. And some equations are not functions at all. So this is like something to be aware of, something to watch out for. All right, we're going to see some examples in a second. But here is some more plugging in. More plugging in. We're going to plug into this function now, f of x equals x squared plus x plus 1. And we have some more complicated things. So we're starting with f of 0 like we did before. But I'm going to have you guys do these two as well, f of x squared and f of x plus h. And it's going to involve some algebra that you have to do. So take 2 minutes, say, and let's try these in Math1030. Example 43 on page 111. OK, there's like 30 seconds left. Put your hand up if you think you need more time to do these. OK, a few people. I'm going to add another 30 seconds here. Okay, let's see what people thought. So I'm going to reveal the answers, or what people said here. Let's start with the submissions. So f of 0, this is just like we did before. That's really like a warm-up. Almost everyone said 1. 1 is correct for f of 0. F of x squared. So there were two maybe reasonable looking answers. One of them is like this, right? Take f and square it, right? F of x squared. That looks reasonable. But this also looks reasonable. And looks like you guys were somewhat split, although pretty heavy majority on this one. And I will tell you, this one is correct. So most people got that one right. So let's take a look at these ones. F of 0, that is just another plugging in. 0 squared plus 0 plus 1, that's 1. F of x squared, so if you understand this one, I think you can go on and do more complicated ones, but just to make sure we know what we're doing, we are inputting x squared into our function. So our function is like a machine. When you input x, you square that, you add it to itself, and then you add 1. Right? Every time you see this x, you can kind of think of it as like the input. The input squared plus the input plus 1. So if you do f of x squared, you get x squared squared, right? The input squared, plus x squared, that's the input again, plus 1. And now you can use the rule that the square of a square, x squared squared, is x to the 4. So this is x to the 4 plus x squared plus 1. So you guys, most people did that one correctly. Let's look at the last one. Let's look at the last one. F of x plus h. 98 people said this. This is the wrong answer. So if you're one of these 98 people, I will tell you for sure, this one is wrong. I'll give you guys another minute. Try to find, if you selected this one, try to find your mistake. This is not the right answer. So think about what it is. I'm going to take it up in a minute. Okay, 5 seconds left. So again, this is very tempting. This is very tempting, x squared plus h squared plus x plus h plus 1, but it's not right. Let's see what is the right answer. So again, you have to think of whatever is going into the function, in this case x plus h, that is the input, right? Wherever you see an x in the original thing, that is standing for the input, and the input here is x plus h. So what should this be? Well, it should be the input squared plus the input plus 1, right? X plus h squared plus x plus h plus 1. And now you got to do some algebra to expand this out to see what it is. And it's very tempting for x plus h squared to write x plus h squared as x squared plus h squared. But if you stop at x squared plus h squared, then it is wrong. It is not true that x plus h squared is x squared plus h squared. There is a famous, okay, maybe only famous to me, famous song that goes square the first term, square the last, double the product, math's a blast. So you got to double the product for math to be a blast. You got to add on plus 2xh. So if you forgot this plus 2xh, then you got the question wrong, because the correct answer is like this, plus x plus h plus 1, copying everything else. That plus 2xh, if you forget that, then you'll get it wrong. By the way, this thing that accidentally thinking that x plus h squared is x squared plus h squared, this is called the freshman dream. It's like freshmen haven't done a lot of math, and they think it's true that x plus h squared is x squared plus h squared, but it's not. It would be so nice if it was. There's a nice Wikipedia page you can read on the freshman dream, which is the name for this algebra mistake. But don't fall for it. So now that you know what it's called, hopefully you will remember and not make this mistake yourself on the exam. So what is the correct answer? Let's go into mathematize. The correct answer, of course, is none of these. None of these was the correct answer. So only 19% of people got it right. I'm sure when I said go back and think about what you did, a lot more also got it right and noticed that the XH was missing from here. Okay. Any questions or comments on that one? Okay, so there's a couple other ones. They're also a little bit tricky. Okay, I guess f of minus 1, that one's easy. This is going to be 1. You can fill it in if you want. But f of square root of x, that's another place where it's tempting to make a mistake. And the mistake in this one is when you do the square root of x all squared. The square root of x all squared. So some people will think that the square root of x squared is just the same as x. It's tempting to write the square root of x squared is the same as x. And again, it's sometimes the same and sometimes not the same. You got to be careful. When is it the same? It's only the same if x is bigger than 0. So you could write when x is bigger than 0 and add that to your our little thing. Let me erase this freshman dream thing so I have more room to work with. So when x is bigger than 0, this is perfectly correct. When x is bigger than 0, or greater than or equal to 0, then it's fine. If x is negative, well, then it's not even defined, right? Because you have the square root of x, and you can't do the square root of a negative number. So the whole expression only makes sense when x is bigger than 0. You got to write down when x is bigger than 0 so people know that this thing, even though it looks like x, it's not defined unless x is bigger than 0. So this is sometimes called the domain rule, and there's a video on it, and it's on your high school algebra quiz. So definitely worth knowing about. Don't forget these when x is bigger than 0 things. The other terms are square root of x plus 1. That's the answer to this one. Was there a question over here? Maybe not. OK. So that's some examples of more plugging in with functions. Any other questions or comments about this one? OK. So yeah, you can plug stuff in. It gets more and more complicated. Here is an even more complicated one. So here is the function f of 1 plus x. F of x is 1 over 1 plus x. And we want to simplify this whole thing. It turns out that this thing is related to calculus. This is related to calculus. So this kind of problem, right now for us, it looks like playing with functions and simplifying, doing algebra. Later on in the course, we're going to do the exact same problem again, and it's going to be related to calculus. And this is going to tell us something about the slope of the function. So if you've seen that before, you know it's coming. If not, I'm trying to tell you guys why you need to be able to do these kinds of simplifications. So I'm going to do this one. This would be a good one for you to practice. There's a lot of algebra steps. I'm going to do the algebra steps in my way. You're going to have a different way that you slightly prefer to do the algebra, and that's OK. So do it however you want. Like the meme says, math is math. So do it however you want. As long as it's correct and you're doing correct algebra steps, you'll get to the right final answer. So here's how I would do this one. I start by just copying everything out. So the function f is 1 over 1 plus whatever is in the input. So it starts out like this. 1 plus 1 minus h divided by 2h. So far all I've done is I've used the different inputs, 1 plus h, 1 over here, and 1 minus h, 1 over here. I'm just plugging in what the function is, and I don't want to do any other steps there because I might make a mistake. So now I can keep going. I can simplify. The top becomes a little bit nicer. 1 plus h is 2 plus h. And 2 minus h is 2 minus h. So there you go. So I did that. And now I have the sum of two fractions divided by a whole other thing. So if you're not good at fractions, or if you forgot how to manipulate fractions, it's easy to make a mistake here. There's two things you got to do. You got to do a common denominator to bring them together. And then you got to do some division to keep track of that. So I'm going to do it like this. We'll bring this whole thing over here. I'm going to write dividing by 2h as a multiplying by 1 over 2h. The 2h on the bottom is a 1 over 2h. And to multiply everything here together, I got to do a common denominator. What is the common denominator? It's 2 plus h times 2 minus h. That's the common denominator. And if you do a common denominator, this first term becomes a 2 minus h. And the second term over here becomes a 2 plus h, right? Because you have to multiply the top and the bottom by the 2 plus h or the 2 minus h to make the common denominator. So that's how I do common denominators. If you want to do it in a slightly different way, that's totally fine. Don't forget the minus sign. So there's a minus sign in between these. And make sure you put the brackets correctly. So that was me doing two things at once. Common denominator, dealing with the addition, subtraction, and then also dealing with the 2h on the bottom at the same time. And now I can simplify a little bit more. So 2 minus 2 is just nothing. Minus h is a minus 2h. So there's a minus 2h on top. On the bottom is 2h times 2 plus h and 2 minus h. Okay, and here is where the sort of miracle happens. There's a 2h on the top and a 2h on the bottom. Those cancel out. So you get just minus 1 over 2 plus h times 2 minus h. And the last thing you can possibly forget is, remember, this is all happening when h is not equal to 0. So when h is not equal to 0, why is it important to write when h is not equal to 0? Well, in the original expression, you were trying to divide by h. You definitely can't divide by 0. In my final expression, that went away. That canceled out. So in my final expression, it looks like it makes sense when h is equal to 0, but it really does not. It came from something where it didn't make sense when h is equal to 0. So it's really important you keep this when h is not equal to 0 there. So that's it. That was like some algebra steps. Like I said before, algebra steps are very personal. Like you're going to have a slightly different way of doing it. It should all be equivalent to what I did. And it's a good skill to practice. This is basically why I'm giving you guys 10% of your grade for the high school algebra quiz. So you guys go home and practice some of these things for that. But any questions or comments about my algebra? Yeah. Which one? The denominator? So when I had this 2 over h and I took it to this? Yeah. So the point is that in this expression, we have something divided by 2h, right? And the something is kind of complicated. So I want to put that on its side and deal with it by itself. And dividing by 2h is the same as multiplying by 1 over 2h. So that's what I did. I kind of took our division, and I dealt with the stuff on top separately, and I did the denominator as a multiplying by 1 over 2h. And that helped me sort of compartmentalize. There's the 2h over here, there's the other stuff over here, and now I can deal with the other stuff. OK, good question. There was another one over there. Maybe we answered it. OK. OK, so once again, look it over on your own time if you found it confusing. It's definitely the kind of thing you just got to practice, practice, practice. OK, next up, we're talking about graphs. So what is the graph of an equation? A graph of an equation is all the x and y that satisfy the equation. So it's all the x's and y's that satisfy the equation. So to give an example, I'm going to skip ahead here to this example, example 45b. Let's look at x squared plus y squared equals 1. What would the graph of x squared plus y squared equal 1 look like? Well, it's all possible xy such that x squared plus y squared equals 1. That's what it is. And if you didn't know how to do algebra, and you just had x squared plus y squared equals 1 in front of you, the only way to graph this is by guess and check. So you could do, let's try x equals 2, y equals 1. And then you would say, OK, well, 2 squared plus 1 squared is 5. That's not equal to 1. Therefore, 2, 1, not in graph. So we don't draw a dot at 2, 1. And then we would try, maybe we try, I don't know, x equals 0, y equals 1. And 0 squared plus 1 squared, 0 plus 1, that is equal to 1. You get very excited. You're like, it is 1. Therefore, the point 0, 1 is on the graph. And if you do this guess and check, you guess and check every single possible point in the whole grid, right? There's infinitely many, but you're really fast, so you can do infinitely many of them. What is your grid going to look like? You're going to have the Cartesian plane, and you're going to have points up here like 2, 1, 2 across, 1 up. No, not here. No point. And then you're going to have the point 0, 1, 0 across, 1 up. You're going to put a yes, this point is here. Yes, 0, 1. So some points are in, some points are out, and you kind of draw a dot every time a point is in. The points that are out, you draw nothing. And if you guess and check enough, it'll start to look like that. The nice thing is computers can do it for us. So see if you can guess. I'm going to tell Desmos to graph it in a second. See if you can guess what it's going to look like. So x squared plus y squared equals 1. When I put in the 1, Desmos is automatically just going to check every single possible point and color in the ones where x and y satisfy x squared plus y squared equals 1. And look at what it looks like. It's a beautiful, tiny little circle. Can I zoom in? I guess I don't need to zoom in. It's a cute little circle. So that is what it means to graph an equation. Of course, this is an extremely tedious process. And in general, you can get like crazy things, right? Like if someone says, I don't know, sine of x times y plus x squared minus y squared equals 0. It's going to be some insane graph. I don't know, like crazy wiggles all over the place, like, right? If you write down a crazy equation, you're going to get some crazy points in the grid that have nothing to do with anything. This one looks like a cool pinwheel. I don't know. Let's make it. Oh, wait, that was cool for a sec. Look at that one. There's some insane graph, right? So if you have some arbitrary thing, it's not going to be a function. It's not going to be a nice input-output relationship. And it could be some very complicated thing. Fortunately, if it's a function, things are simpler. So if there's only one y value for every x value, then you can simplify things. Instead of checking all possible x and y pairs, you just plug in different values of x and find what the y is. So to give you an example of that, let's look at y equals 2x minus 1. For y equals 2x minus 1, instead of plugging in x's and y's, why don't I just plug in some x's? So let's do x equals 0, x equals a half, and x equals 2. And we'll find out what the y value is. So this is a little bit easier than kind of checking all the possible x's and y's. So when x equals 0, you get 2 times 0 minus 1, y is minus 1. And when x is a half, you get 2 times a half minus 1, which is 0. And when x equals 2, you get 2 times 2 minus 1, which is 3. So you get these points. On your axis, you have the point 0 minus 1. That's some point over here, 0 minus 1. 1 half comma 0. That's some point over here, 1 half 0. And 2 comma 3, 2 comma 3. Okay, so it's a lot simpler. If y equals f of x, then things can't look crazy. It's just going to be y equals 2x minus 1. It's going to be a connect the dots. It's going to be a line. And those are the points we found. 0 minus 1, 1 half comma 0, and 2, 1, I guess, is over here somewhere. OK, 2, 1 is somewhere on there. So the point is, if it's a function, it's easy to graph. You just plug in the x values. If it's not a function, it's very hard to graph. There is a trick sometimes. You can get lucky, and a non-function can be manipulated, massaged into a function. So this implicit equation over here, implicit equation, x squared plus y squared equals 1, you can turn it into two explicit equations. Y equals plus square root of 1 minus x squared, and y equals minus square root of 1 minus x squared. How would you do that? Well, just by algebra. So if x squared plus y squared equals 1, then y squared is 1 minus x squared. And if y squared is 1 minus x squared, I can do the square root of both sides to get the square root of y squared is the square root of 1 minus x squared. And the last step is to know that the square root of y squared is not just y, it's either y or minus y. So you be careful with that. OK, rather, the square root of y squared is the absolute value of y, right? If y is negative, then it could be positive or negative. I didn't introduce absolute values. OK, let's just say it's a plus or a minus. Therefore, minus y is equal to this stuff, 1 minus x squared, or y is this stuff. So you have two functions, right? From the implicit x squared plus y squared equals 1, there are two possible functions, plus square root of 1 minus x squared or minus. Let's see that in Desmos. OK, x squared plus y squared equals 1. That's the circle. Y equals the square root of 1 minus x squared, x squared minus 1. Nope, I wanted it the first way, 1 minus x squared. There's the top half, and y equals minus the square root of 1 minus x squared is the bottom half. So you can make the purple circle can be made of two halves, a top half and a bottom half, and both of those are functions, easy to graph, whereas even this implicit thing maybe is hard to graph. OK, and what else is there? There's the table. This is the table of values. Just like we made a table of values for y equals 2x minus 1, we can make a table of values for these two functions. And on our table, we have x is 1 and minus 1, where y equals 0. And when y equals 0, or when x equals 0, y is either plus 1 or minus 1. So the 4 points on this table look like this. There's 2 points at the top when x equals 0 and y is 1 and minus 1. And there's 2 points on the side where x is 1 and minus 1 and y equals 0. I think if you're going to draw this little cartoon, you just think circle. It's going to be a circle. I don't know. This is a circle. A circle. OK. All right, so that was a very complicated story about graphing equations versus graphing functions, an example of an implicit equation that can be turned into functions. Lots to unpack there. I'm sure you guys have seen graphs before, but this is a good reminder of what they are. Any questions or comments about that? OK. So there's another example over here. I'm going to record a video and post it as an extra video of this one. You can also try it on your own, or you can put it in Desmos and see. I encourage you guys to fill in the table. The reason I'm going to record later, or extra video, is because I want to start the next section. So we're going to start section 5.3 over here. I'm hearing a lot of chatter. Maybe people can quiet down. All right, thank you. So we're starting 5.3. You should try this one on your own. Watch the extra video if you want to fill in your note. It's another example of a function. So the next section is about points of intersection. How do you find the intersection between two graphs? And we're going to learn one really basic technique called the method of substitution. So we want to solve two equations simultaneously. One of them is some equation with an f. One of them is some equation with a g. And in the method of substitution, we take one equation and we write it in terms of y equals something. So we make it explicit, and we plug it into the other one. And there's three things that can happen. Either there's no solutions, or there's some finite number of solutions, like 1, 2, or 3. Or maybe there's infinitely many solutions. So here's a small description about the method of substitution. But I think the easiest way is to see it in action. So here we're going to do this problem of finding all the possible points of intersection between two things. X squared plus y squared is 25, and x plus y equals 2. And you should recognize these equations based on what we've done. X squared plus y squared equals 25, this is a circle. This is the equation of a circle. Whereas x plus y equals 2, this is a line. And so what is going to happen is we're looking at one of them is a circle, one of them is a line. They're going to intersect in some number of points. To really drive it home, let's graph them in Desmos. So let's graph the two equations we have. The first one is x squared plus y squared equals 25. And the second one is x plus y equals 2. So the first equation represents that blue set, right? It's a set of points, x and y values, where x squared plus y squared is 25. And the second one is x plus y equals 2. And the question I'm going to ask you guys in Mathmatize is not to solve the full thing, which I'm going to do, but just how many points do you think there will be? How many intersections are there? And you guys tell me how many there are. It's not too hard. I'll give you just 1 minute for this. OK, just a couple seconds left here. How many solutions do you think there should be? OK, let's see what you guys said. How many solutions? 2. Most people said 2. That's how many I think there should be as well. Let's see. Some people said more than 2. OK, 2 I think is correct. I'm just counting. You know, there's going to be 1 up here, 1 over here, and 1 down here. You can see Desmos tried to solve it for us, right? But Desmos did it with decimals. It's not an exact answer. Let's see how we would find these 2 points with algebra using the substitution method. So to find them, we are going to plug one into the other. So what I'm going to do is I'm going to manipulate an equation. So write one equation as y equals something, stuff. Then plug into the other. Plug into the other. That's my strategy. This is called the substitution method. So this only works if one of them can be manipulated into y equals stuff. Of the 2 equations, x squared plus y squared equals 25 and x plus y equals 2, the second one actually looks really easy. The second one I can write as, so 5.2 is y equals 2 minus x. And if y equals 2 minus x, and I plug that into the first equation, so if I plug into 5.1. What do I get? I get x squared plus 2 minus x squared equals 25. So I've plugged in y equals 2 minus x. I put that in for y. And this is a quadratic equation in x. So if you know how to solve quadratic equations, you're good at quadratics, you can nail this one. So let's see, how would we do it? I'm going to start by expanding it out. So x squared, 2 minus x squared, square the first term, square the last, double the product, math sub last. See, it came back. OK. And now we have a quadratic equation like that. I can clean it up a little bit more. That's 2x squared minus 4x. The 25 and the 4 can come together to make a minus 21, and that's equal to 0. So by taking one equation and putting it into the other, I got a quadratic equation for x. And now there's a super secret method to solve a quadratic equation. Solve a quadratic equation using, how would you solve a quadratic equation? What would you use? Yeah. The quadratic formula. There's just a formula. It's so nice. So if once you have it like this, there's a formula. You put it in the formula. You get the answer. So the quadratic formula. So this is the nice thing about quadratics, is they are so simple in that there exists a quadratic formula. You put it in. You get the answer. It can't go too complicated. If it was a cubic equation or a quartic equation, then we would really be in trouble. But for quadratic, we're laughing. And I'm going to, so there's a video online about quadratic equations and the quadratic formula. I'm not going to go all the details of how you get from here to the answer. I'm just going to tell you guys what the answer is. So, and there's a video online already with this. So use the quadratic equation. This is a good practice. Again, for the high school algebra quiz has the quadratic equation on it to get. And you get these two answers. X is equal to 1 plus the square root of 46 over 2, and x equals 1 minus the square root of 46 over 2. And we can check and make sure that that is correct by, in Desmos, seeing what those look like. So if x equals 1 plus the square root of 46 divided by 2, that's that purple vertical line. And if x equals 1 minus the square root of 46 divided by 2, that is that black vertical line. And you can see that it's actually, it's working out perfectly well that we have found the x coordinate of the points of intersection. To complete the answer, you want to find the y values too. So now we're going to find the y values. To find y values. And again, to find the y values, you know the x values. You have two equations. It's your choice which one you want to use. Do you want to use the first equation or the second equation? Well, the second equation is a lot easier. So y is 2 minus x from the second equation. That is what we did up here. Y was 2 minus x. And so if you plug that in, you get x is, when x is 1 plus the square root of 46 divided by 2, y has to be 2 minus 1 plus the square root of 46 divided by 2, which is 1 minus the square root of 46 divided by 2. So that's one solution. X is 1 plus the square root of 46 divided by 2. Y is 1 minus the square root of 46 divided by 2. And you can check that it works. We can do 1 plus the square root of 46 divided by 2. And we can do 1 minus the square root of 46 divided by 2. And look, we have that red dot. We perfectly found this red dot over here. So that one works. What about the other one? What's the other one? When x is 1 minus the square root of 46 divided by 2, y is 2 minus that, also known as 1 plus the square root of 46 divided by 2. So it's kind of the mirror image of this. All the pluses turn into minuses. It's this point. 1 minus the square root of 46 divided by 2. 1 plus the square root of 46 divided by 2. OK, so we got that blue dot up here. So we've solved it. If you want to see the details of how the quadratic formula works, go watch the extra video online. And I'll see you guys on Wednesday.